We're going to take a look at manual transmissions and how they're set up, power flow through the manual transmission, lubrication, and some of the shifting components that are in the manual transmission itself. Now, manual transmissions come in a variety of different sizes, different gearing. One of the things we want to look at is countershafts that are in the transmission. Now, having a single countershaft transmission, a dual countershaft, or a triple countershaft transmission, the only difference is how the load is transmitted through the countershaft. Now, in a single countershaft transmission, the whole load is placed within that one countershaft. When we get into twin countershafts, the countershafts split the load, and in triple countershaft they're divided by 3. So what we want to take a look at is, and again we're just going to deal with how power flowed through one of the countershafts, because the countershafts are all timed, so whatever's happening to one is happening to the other. So for instance, if we take a look at the input of a transmission, from the clutch or from the engine, it comes into the input gear, which is timed to the countershaft gear. Now we want to take a look at compound gear ratios, and again, a compound gear ratio is driven over drive times driven over drive, output over input times output over input, mechanical advantage of one times the mechanical advantage of the second. So if we take a look at the first set of gears, our input's 21, our output's 33. So driven over drive would be 33 divided by 21. And then when we go to the second gear ratio, again, now our countershaft is our input and our output is on our main shaft. So it would be 33 over 14. When we do our math, we get a gear ratio of 3.928 to 1. Now gear ratios are always to 1. If we have an overdrive, it will be a decimal, like 0.98 or 0.75 to 1. It'll always be to 1 because that is what our output is. Now we take a look at every transmission manufacturer has a way of identifying what's inside the transmission. So for instance, an Eaton Fuller transmission, RTLO, so it's a Road Ranger, it's a twin countershaft, it's low inertia, it's an overdrive, and we're going to talk about shifting later and how it's set up. And then there's a CRF. So for instance, if we have a vehicle that's got a set back engine, so the engine's set back further, the transmission has to be set back further. So what we're going to have is on the shift cover itself, this shifter will be placed further forward, so it'll have a forward mounted shift housing. Then we get into the last set of numbers, and so what we want to know is how many gear ratios there are. So on this one here, there's 18 forward speeds, and that's what we want to look at, because we can have a transmission with 9, 10, 13, 15, 18 speeds, depending on the configuration and how it's set up. And we're going to take a look only at the front section. The rear section will be in a separate video. Now, when manufacturers manufacture a transmission, what they want is they want the percentage between each gear to be relatively the same, so that when we're going to shift from, say, first gear to second gear to third gear to fourth gear, and so on, we don't have a large percentage increase. So that means that we don't have to over rev the engine in order to shift to the next gear, and then the engine doesn't lug. So they want them all the same, so that we're fairly consistent in at what RPM we're going to shift without lugging the engine down. So another type of transmission that we have is we have an extremely low range, so that when we're in low range, before we shift from low range into direct, we have to, in some cases, stop the vehicle because it just will not shift from low range into first gear. Now we take a look at an RTLO, which is an overdrive transmission, and how the power flow works inside the transmission. So if we take a look at the input of the transmission, the input comes in, and even though this says fourth, this is the main set gear, which turns our counter shaft. Now the power flow through here depends on which of these yellow sliding collars is engaged. So let's just start out with reverse. So power flow comes in, turns this gear, which is always connected to our counter shaft gear. Our counter shaft gears are all pressed together, so anytime one of them is turning, they're all turning. Now they are also connected to our main shaft gears, but our main shaft gears float. They are not connected to anything unless one of these sliding collars is moved into that gear to engage it. These sliding collars are splined to the main shaft, and so anytime that we're in neutral, for instance, input is turning, this gear is turning, our counter shaft is turning all of these gears, but because none of the sliding collars are engaged in the gear, we get nothing on our output. If we take a look at all our gear ratios, we can take a look at our input. So again, it'd be driven over drive, and then depending on, let's just say we're in reverse. So it'll be 66 over 52 times 46 over 17. Now again, to get reverse, we have to have a reverse idler. Reverse idlers are not counted in the gear count, just the gears. Now when we're speccing out trucks, what's the vehicle going to be used for? Is it going to be used around town, no hills, hauling light loads? So we might be able to get away with a 5-speed transmission. If we're hauling a little bit heavier loads on a single axle, we can have a 2-speed rear axle. So that would give us 5 speeds in the transmission plus 2 speeds in the rear end, which would give us 10 speeds. So each gear in a case like that would be split. So we would start out in first low, go to first high. Then when we go into second, we have to put the splitter back into low range. Then we go second low, split, second high. Then put it back in lower range, go third, and so on and so on. When we get into heavier vehicles, we need to have more speeds because the gear ratios are needed to be able to get that vehicle up to speed in order to move it. So again, it will depend on how the vehicle is spec'd out, how many speeds that transmission has. There are some heavy movers that will have 2 transmissions, and that's to get extremely low speeds. But they can put the transmission in direct drive, which then would be 1-to-1, so they don't need to use that second transmission. They can drive at road speed. When we get into commercial buses, for instance, a lot of the commercial buses are automatics, but at one time they were a manual transmission where you had a mechanical linkage from the front to the back to the transmission that would allow it to shift. And again, we have heavy movers, and they may even have outboard planetaries, and this is going to give them an extra gear reduction in the outboard planetary. In most cases, the transmission is mounted directly to the rear structure of the engine, and in between the input of the transmission and the engine, we're going to have a clutch so that we can disengage the transmission to allow for shifting between gears. And anytime we're going to be shifting forward to reverse, we have to disengage the drive and stop everything to allow us to go into reverse. If we take a look at the very basic transmission, again, From our input, we're going to go into our input gear, which is going to run our counter shaft. Now, if you notice all of this transmission here, they're helical cut gears. And if you remember from any time we were talking about helical cut gears, we get an axial load, so they're going to use tapered roller bearings. And anytime we use tapered roller bearings, we have to shim them. A lot of our newer transmissions now just use straight roller bearings and straight cut gears in the front section, so they don't have to be shimmed, but in the rear section, if they use tapered roller bearings, they have to be shimmed, and we're going to discuss that when we get into the rear section. Looking at the counter shaft, again, the counter shaft gears are all keyed to the shaft so that they all turn at the same time. There will be a timing mark on the counter shaft somewhere, because again, the counter shaft has to be timed to our input gear. That's the only one it has to be timed to. Again, looking at these gears here, so on a single counter shaft, it doesn't have to be timed in most cases, but the book will tell you whether it has to be. The other thing that we're going to take a look at later on is the shifting patterns and synchronized transmissions. Now, the main shaft of a transmission, all the gears float on the main shaft. If it's a single counter shaft transmission, there will be bearings because of the radial loads that are placed on this. But on a twin counter shaft or a triple counter shaft, the gears just float on the hardened shaft because they're balanced between the two counter shafts or the three counter shafts, so they don't need a bearing in there. So we take a look at the input and main shaft of a transmission. So this is our input, and again, it doesn't matter whether we use tapered roller bearings or straight roller bearings, how they're set up. So this is a single counter shaft transmission, so it uses a synchronizer. So it'll have a synchronizer on second, third, and fourth, fifth. First and reverse usually don't have synchronizers on them, so they're just not needed. So because we're starting from a stop. One of the things on a single counter shaft transmission is which gear gets used the most, and that's usually second gear. So second gear usually gets used the most. The second gear synchronizer is usually the first one to wear out. So it's something to pay attention to. And how does a synchronizer work? Well, what happens is when we're going to shift from first to second, second to third, third to fourth, and so on, as we move our stick inside the cab, it's going to move this synchronizer. And the synchronizer is going to get forced up against this blocking ring. And then what that blocking ring is going to do is it's going to slow this gear down. Remember, these gears float on the shaft. It's these sliding collars that are splined to the shaft. So when that happens, our blocking ring gets pushed ahead, slows this gear down, and allows that sliding collar to mesh with this and engage into this main shaft gear, which now locks it to the main shaft. So this is with the sliding collar through the blocking ring and through this gear. So it's locking this, and again, remember, this is splined, the sliding collar splined to the main shaft. So any time that the main shaft is turning, these sliding collars will be. And it works the same when we're dealing with twin counter shafts. So this is just a different style setup that they have, but still it's a synchronizer. We take a look at our shift tower, our shift cover. Again, it will be set up to allow it to sit inside and shift the shift collars. There are a bunch of different styles of synchronizers, and when we're dealing with highway vehicles, we're going to take a look at our synchronizer. Synchronizer is only in the rear section, and we'll be taking a look at that more in depth when we take a look at the rear section. But in this case here, these are our blocking rings, so as we're going to shift, this will load this blocking ring into this cup. This cup is splined to this gear, so it'll slow this gear down, because again, remember, this gear floats on the shaft. This is the synchronizer when it's engaged and when it's disengaged. And we have pins that will help slow this down to allow for a little bit of torque, and it'll allow it to shift easier. Now again, when we're taking a look at a twin countershaft transmission, we have the two drive gears, or two countershaft gears, and our input gear that really, again, it floats in between it, so it's just distributing the load evenly between the two. In a countershaft, triple countershaft transmission, we're dividing it by 3, and again, they all float in between these. Now again, the input shaft is not directly connected to the main shaft. Again, the countershafts always turn, but it's not until the sliding collar on the main shaft engaged into a gear do we get any output. We're going to take a look more in depth at that. Now one of the things when we're taking a look at the input or the main set gear is they have to be timed to the countershafts. So the timing marks are on the countershafts, not on the main shaft. So on the input gear, we're going to mark it 180 degrees apart with 2 marks. So make sure you can count the teeth and divide by 2 evenly, and then make sure that it's set up properly. Because if it's not timed properly, the transmission will bind up. In a triple countershaft, I've seen it where it wasn't timed properly, and it actually split the case, the aluminum, the gear transmission case. So make sure that you spend the time to count the teeth and make sure you know where your timing marks are. And again, we only have to time the front countershaft gear with the input gear. That's it. All the rest will fall into place because they float. Now taking a look at we're just going to deal with the front section. We're not going to deal with the auxiliary section at this time. So we have our clutch housing, we have our shift fork that disengages our clutch, we have our shift cover with our shift rails, and we have our main section. We also have our air shifting setup, which will allow us to go from low range to high range, and in some cases we may also have a splitter. The air system is discussed in a future video. When we take a look at the breakdown, we have our master control valve, and again, that's part of our air shifting. Will be discussed in a further video. Our shift housing assembly. Now, in our shift housing assembly, depending on what type of setup we have, whether it's an RTL or an RTLO, will determine how our shift housing is set up. We can't just take shift tower off of one transmission and put it on another if it doesn't shift properly because of the overdrive. On a triple countershaft transmission, a Mack, again, the basic function of all transmissions are the same. They have 3 shift rails here, which will allow us to shift the main shaft between all the gears. One of the things to pay attention to when we are putting the cover back on the transmission is the length of the bolts that go through here. There's one gear that you can't see here, and if we put a bolt that's too long, it's going to go down and it's going to lock one of the gears in place, and the transmission won't spin. And if we're not paying attention when we assemble it, and we don't check to make sure that it goes through all the gears, and we stick it in the vehicle and we start the vehicle up, put it in gear, release the clutch, it's going to shear that bolt off, and that bolt could get jammed between some gears and wreck the transmission before it even gets out the door. So always check your transmissions once you've finished rebuilding them to make sure that it goes into all of the gears and doesn't bind. If we take a look at the input shaft, again, the new style input shafts are made so that if the splines are worn, we can replace this input shaft without disassembling the transmission. So what we have is we have an outer snap ring that fits into a groove on the input shaft. We have our bearing, we have a spacer, and another snap ring. So when we go to disassemble this, we're going to pull this outer snap ring off. We're going to pop this bearing off, and it's usually if you get two heel bars in behind the big snap ring on this bearing, we can pop that out. Take our spacer out, take the inner snap ring out that goes inside this gear, then we can pull our input shaft out. And to reinstall it, we just do the reverse order. One thing to pay attention to when we're putting a new input shaft in, make sure that there's a bushing here. And put some grease inside that bushing before we assemble it so that it doesn't start out dry. When we're reassembling, one of the things that we have to pay attention to is we put the input shaft in, and it can come out through the front of this gear. So we're going to stick the input shaft in, put the snap ring in place. That prevents it from moving out. Then we're going to put our spacer on, which goes on here, and then our bearing. One of the things we have to really pay attention to is this outer snap ring. Now, if you remember back from when we were talking about seals, on the input shaft of a transmission they have what's called a wind-back seal. As the input shaft is turning, it draws the oil back in so it won't allow it to leak out. We don't want to accidentally install that snap ring on the wind-back grooves. There is a groove for the snap ring, and it's further back, so we have to make sure that this bearing's pushed all the way back so that we can install it properly. Once that is done, then we can tap the end of this input shaft with a rubber mallet. Never use a hammer because you'll mushroom the end of this. Now, when we're doing the inspection on transmission, let's just say, for instance, we're pulling the transmission to replace the clutch. We want to inspect the input shaft. We're going to talk about this later when we're doing clutches, but we want to inspect the input shaft to make sure that where the pilot bearing sits isn't worn, and where the splines are, that they aren't worn, because if they are, well, we got the transmission out. It's quick and easy to replace this input shaft, and we should do it. Otherwise, we're going to have premature wear on the new clutch plates. Now, taking a look at the counter shafts. Now, if you take a look at the counter shaft gears, because they're straight cut gears, we're just using roller bearings. We don't need to have tapered roller bearings in this because we are only dealing with radial loads, not axial loads. Now, all of these are pressed on, so if we have a gear that's failed for any reason, we can press it off the shaft, replace that one gear plus the gear that's on the main shaft if it's been damaged, and then reassemble it. When we're looking at the main shaft itself, so the main shaft inside the transmission, if you remember back from when our input shaft was, and I was talking about the bushing, that bushing fits in here on the main shaft. Now, our main shaft does not turn unless one of our sliding clutches is engaged in our gear. Inside each of these sliding clutches, they're splined, and they're splined to the main shaft. The main shaft, if you take a look, has a keyway. Each of these sliding clutches will be missing one tooth. And that one tooth that's missing is to allow it to slide over this keyway. Be very careful when we're disassembling this. Don't hammer on the keyway to try and push it forward. You'll break off this one spring pin, and if you break it off and you can't drill it out, you got to replace the main shaft. Now, all of these gears, again, float on the main shaft. They don't touch the main shaft, they just float around it. It's not until this sliding clutch is pushed inside that it actually locks in place. Now, older types of transmissions used to have different thicknesses of spacers, and that would allow your clearances between your two gears for oil. And if it wasn't tight enough or too loose, then you would adjust with different thicknesses of these spacers. The newer models of transmissions all use the same spacers, and you'll see that when you go to assemble your transmission. The other thing to pay attention to is to make sure that when you're assembling your transmission that your gear washers are in the correct order. Now, in some of the transmissions, one of the gear washers is a different thickness, and if you put it in the wrong place, you won't be able to lock your gear in place. When we take a look at reverse idler gears, now again, a reverse idler gear is just another gear between two to give us a change in direction. When we're removing and installing our reverse idler shaft, they use a spiral snap ring, and in most cases when removing this you're going to damage it, and if it's damaged, don't reuse it. Always put a new one on. Now there's a bolt that runs through the shaft, and the bolt you can put in a slide hammer to pop these pins out. When we're going to reassemble it, one of the things to pay attention to is the direction of the gear. In one direction it will spin freely, but if we put it in the other direction and tighten it up, it jams up against the case and it won't spin. Making sure that the bearings and the inner race are in good shape and that we use the two thrust washers that go on there. Now, some of the newer transmissions will use one of these spiral snap rings on each end. When we're taking these out, again, don't hammer on the threads that are in there or you'll damage them and we'll never be able to use a slide hammer on it. Now, power flow through a transmission. We're not going to discuss the rear section, we're just going to discuss the front section. Rear section will be discussed in a further video. So from our input shaft comes into our input gear, and again our input gear is timed to both of our counter shafts. Now, if this sliding collar is in the center, these counter shafts turn, all these gears turn, but we don't get any output. So in reverse, when we take the sliding collar and engage it into the reverse gear, and again, because the sliding collar is splined to the output shaft, we'll get an output. Now when we go into first gear, what we're going to do is we're going to take this sliding collar and we're going to move it out into the neutral position and then engage it into first gear. So the power flow is again through our counter shafts into our first gear and out. When we go into second, we're going to disengage this collar and we're going to engage this collar. So our power flow will be the same. Now again, remember, this counter shaft's turning, these gears are all turning. So when you're working on the transmission, don't stick your fingers in there, you're going to probably lose part of it. When we want to go from second to third, we'll disengage the sliding collar from here and move it into here. When we go into fourth, we're going to move the sliding collar into this one. And then when we go into fifth is direct. Even though the counter shaft and all of these gears still turn, our main shaft is now locked to the input shaft. So this is going to give us a gear ratio of 1:1. Now there is one difference, is when we have a transmission that's an RTLO. It's an overdrive transmission. And one of the ways by just looking at the transmission is if we take a look and this gear here is bigger than this gear here, we have an RTLO. So as you can see, we go small gear, bigger, bigger. If we go bigger and then smaller, it's an RTLO. Now what that does is, remember, direct drive would be 1:1. Overdrive would be, let's say, 0.87:1. So with that, our shift cover is going to be a little different because of our shift pattern. And we're going to discuss shift patterns when we take a look at the cover and how they're set up. Now, one of the things that when we go into direct, we still have one more gear, which would be fifth or overdrive, which used to be third, which goes through this way. This is going to give us our overdrive. Now, one of the things we haven't discussed, we have an extra gear here. Now, depending on the transmission, these are our PTO gears. Now, our upper and lower counter shafts can be different depending on the PTO gears they have in them. So when you're taking your transmissions apart, make sure that you mark them upper and lower so that we can put them back in the original spot. There are some of the transmissions, the lower counter shaft will not fit where the upper counter shaft is because it'll hit the housing. So if you go to reassemble and you can't get your bearings in, it might be because you have the wrong counter shaft in. Now, the counter shafts also do something else. The counter shafts will run the oil pump that feeds all the gears. So we might have an oil tube that feeds all of these gears to make sure that they stay lubricated. When we're climbing a long hill, for instance, all the oil flows to the back of the transmission. We want to make sure that we can pump that oil back up to this main set so that it doesn't run dry. We also have a thing on the shift cover, which is built in or is attached to the shift cover, that because they're splash lubricated will help feed the main set. Now, when we take a look at the shift housing itself, now this is the tower that fits on top of the shift cover, and it allows us to shift between the gears. One of the things to pay attention to is how the shift housing came apart, because in some of them you can install them backwards if you're not paying attention. And I've seen it happen where it was installed backwards, so when you go to shift into a forward gear, it pops it out and you're stuck into a neutral. So just be aware of which way it goes. When we take a look at our shift cover, this is where our shift housing will fit on top. We have 3 detent balls and 3 springs. We also have a reverse light switch, so when we go into reverse, it's going to actuate this switch and turn on our backup lights. This is where our RTLO and our RTL differ. This actuating pin with this actuator reverses our 2 gears, so our shift pattern will stay reverse, first, second, third, fourth, fifth, or overdrive. So again, we have to make sure that this actuating pin doesn't have a lot of play in it. Now, this is the oil trough I was telling you about. Now, this oil trough, because most transmissions are splash lubricated, it will feed up and put oil into this trough, and that trough will drain that oil into the front main set. We also have our 3 shift bars, our shift rails, with our forks on them. Now, the other thing that we have is we have, again, our detent balls that go into the detents. And what these detents do is they allow, once we shift, it holds that into gear. As they start to wear or the springs get weak, it can pop out. So, taking a look, here's our oil trough again that's going to feed up into our main set. We have our 3 shift forks that fit into our sliding clutches. And again, anytime we're assembling a transmission, we should always make sure that once we assemble that it does go into gear, because if one of these slides ahead and we get in the wrong position, we're going to try and get 2 gears at once, and it's easier to check everything while it's on the floor than it is to try and check it once it's in the truck. The other thing to pay attention to is this little pin that's here. This is the actuating pin for our high-low range into our slave valve that you can't see off to the side. And what happens, a lot of people drop these covers on, and this little pin that's here breaks this off. Now, the easiest way to prevent that from happening is to take our slave valve off first and put it back together last once our cover's on, so that we don't break it. So our detent balls, again, they go into the shift rail. So this is a neutral position. This would be a forward gear and a reverse gear, or 2, 3, 3, 4, 4, 5, whatever. It holds this shift rail in position so it can't pop out. The other thing we have is when we go shift into reverse, there has a little bit more resistance. We have to actually force it to get this, compress this spring to get it into reverse, and this prevents us, so when we're going to shift from first to second, we don't accidentally miss and go and try and go into third. So as we move this over, coming this way would be first, pushing this up and going this way with the shift rail would be reverse. So when we go first, we're going to go into second, third. So as we go into second, if we miss this, we can't accidentally push it into reverse. The other thing, again, we talked about the detents and balls. Anytime we've moved the shift cover, make sure that these springs and balls stay in here. And if we're doing any work, we can use a magnet to pull these little detent balls out. Make sure that they don't drop inside, because if we do, we have to fish them out. The other thing we have on our cover is a thing called an interlock. And an interlock prevents us from engaging two of the shift rails at any time. So we don't want two of the shift collars moving at the same time. So this interlock will only allow one shift rail at any given time to move. So when we're disassembling our shift cover, we want to make sure that we don't lose our detent balls, or our balls that are on our interlock. So always make sure that when we put them together that they stay there. Now how that works is anytime we move one of our shift rails, it pushes this interlock around and locks this ball into this shift rail so it won't move, and this ball into this shift rail so it won't move. Now when we want to shift into another gear, this top shift rail is going to move back, which then will allow any of the other two to move. Once that moves, this will prevent the other two from moving. Now some of the older transmissions on our auxiliary section were separate from the transmission. All our new ones now, the auxiliary section is bolted to the back of the main transmission. So they had mechanical linkage for those. But this is how our new ones are set up, where we have our air shift. So with that, we're going to discuss later on in a future video about how our air systems are set up to shift our auxiliary sections. So that's it for the main section of the transmission. The next will be the rear section.